Welcome back. Let's talk about some of the things that atoms try to do to attain that quality of stability. Remember, we said that atoms want to be stable and that they'll go through various types of interactions to try to gain that stability. They might lose electrons, they might gain electrons, they might share electrons with other atoms, all in an attempt to become stable. Now, stability is when an atom has all of its its outermost shell filled with electrons. That valence shell is filled to capacity. So remember, we're thinking of atoms as wanting to become stable and going through interactions with other atoms to attain this stability. Let's remind ourselves about what the capacities are for those different levels in terms of the energy levels in the electron cloud of an atom. That first energy level can hold 2 electrons, and then we would say it was filled. Second one, 8, also filled at that point. And then the third energy level, we're going to say will be filled, or at least sufficiently filled, when 8 electrons are present in the third energy level. And remember, that's what these atoms are striving to achieve. Let's remind ourselves of a few of the different atoms. These are 4 of the big 6, the chinops that we had talked about before. And as you can see, all 4 of these are unstable atoms. They do not have filled valence shells, which means they're all going to be looking for opportunities to gain stability, to fill that valence shell. One of the ways that this can happen is through the process of ionization. Now, with ionization, an atom is actually going to be either losing an electron, typically to some other adjacent atom, but losing an electron, or other atoms might go through the process of gaining electrons. Remember, all in an attempt to try to fill that valence shell. Now, if I have an atom that gains an electron, it's also gaining a negative charge. And as a result, it's going to become what's called an anion, or a negatively charged atom. If an atom loses electrons, well, think about what it's losing. It's losing one of its negative charges. And so as a result, it's going to become a positively charged ion, a cation. So, ionization is this gain or loss of electrons. And as a result of gaining or losing electrons, atoms become charged. They become ions, either negatively charged anions or positively charged cations. Let's take a look. Let's see an example. Here we have 2 elements, 2 atoms, that each are unstable. Their outermost energy level, their valence shell, isn't filled. Sodium, as you can see, has only 1 electron in its third level. Chlorine has 7 electrons in its third level. Both of them are unstable. And if they come in proximity to each other, then something that can happen is that an electron can leave the sodium, move to the chlorine. Well, you see what's happened. Both of them have become stable. If we look at either one of these 2 atoms now, notice that their outer energy levels are filled. They've both attained stability, but they've also both become charged. Sodium has become a cation. It lost a negative charge. Chlorine has become an anion. It has gained a negative charge. Let's look at that a little more closely so you can see exactly what I'm talking about. Before ionization, let's focus on what happened to sodium, just so we can see this idea of how the charge of the atom has changed. Before ionization, what did we have with sodium? It had 11 protons, 11 positive charges. It had 11 electrons, 11 negative charges. So that means in this undisturbed state, in its original state before the ionization, it was neutral in terms of its charge. What's that mean in terms of its electron distribution? Remember also is that it had 2 in the first energy level, second energy level had 8 electrons, that third energy level had 1 electron. So even though it was undisturbed, even though it was neutral, we would say that the atom wasn't stable, because notice that third energy level is not filled. All right, so now what's going to happen during the ionization process? Well, look at the change. Since I'm sodium, I still have my 11 protons. That hasn't changed at all, but my number of electrons has changed. Now I only have 10 electrons. That means the number of charged particles I have has also changed. I still have my 11 positive charges, but now I only have 10 negative charges. That means I have one more positive charge associated with the sodium. Now realize that the sodium has just been disturbed, right? We've changed its structure in some way. And in being disturbed, it has become stable. Think about what its present electron distribution is right here. 2 electrons in the first energy level, 8 in the second. That second energy level is now its valence shell, its valence level, and it's filled with electrons. Sodium has attained exactly what it needed, what it wanted. It has become stable. At the same time, however, it has become charged. Since it has a positive charge, we would call it a cation. So that's the concept of ionization. Realize that ionization has to occur before any kind of ionic bond can take place. So do not confuse ionization for ionic bonding. Clearly they're intimately related to each other, but notice up till this point, all we've talked about is the ionization event. And now we're ready to talk about how this then gives rise to the ionic bond that can form. Ionic bonding is when two oppositely charged ions are attracted to each other by electrostatic attraction. Remember, we said positively charged things and negatively charged things attract each other, that those differences in charges create a kind of pull or force on the ions, and that's the glue, so to speak, that will cause two ions to stick to each other. That glue, that attraction, that electrostatic force is the ionic bond. So now let's go back to our sodium and chlorine. Notice, once again, we see in the left-hand part of this illustration that the ionization event is taking place. Once the ionization event has taken place, then the positively charged sodium will be attracted to the negatively charged chlorine. By the way, what you should do is take the time to draw out for yourself and go through the same kind of process I did with sodium for your chlorine atom so that you can see how it became a negatively charged anion. Now, once they've gotten this charge, then they pull against each other, they're attracted to each other, and we would say that there is an ionic bond. The ionic bond is that force of attraction. Well, with sodium and chlorine, and you've seen it, you've seen large aggregates, connected, concentrated groups of atoms of sodium and chlorine that get together in a crystalline structure. And so when we have an ionic compound, something like salt, it commonly will organize itself into this kind of crystalline structure. And this is a good example of an ionic compound. There are others. Take a look at your periodic table and see if you can find other atoms that might be able to form ionic bonds. Let me give you a little bit of a rule of thumb. What I tend to find is that when I see atoms that have 1 or 2 electrons in their outermost energy level, valence shell, or if I see atoms that have 6 or 7 electrons in their outermost energy level, then those are the kinds of atoms that I expect or would predict might be able to form ions and therefore would be able to form ionic bonds. Give it a try and see if you can find some other examples. Let's think about what we were talking about in this presentation. We started our discussion with the idea that atoms desire or have this tendency to want to be stable. Remember what stability is. Outermost energy level filled with electrons. One way to attain stability is to go through ionization. You might lose electrons, you might gain electrons, but the point of doing that is to fill or have a filled outermost energy level. Once that happens, remember what occurs. The atom becomes an ion. It's now been disturbed from its normal state. It has gained stability, but it's also become charged. If it's a negatively charged ion, it's an anion. If it's a positively charged ion, it's a cation. Oppositely charged ions attract each other. That force of attraction is what we call the ionic bond. So consider that, take a look at it, and then, of course, let me know if you have any questions about it. We're going to continue with this idea of chemical bonding in the next video, so make sure you take a look at that and consider the other ways in which atoms may gain stability. Thanks very much. Talk to you next time.